This is the second of the fourth lecture in aldehyde ketone, looking at strong nucleophiles for aldehydes and ketones, and we're going to be looking at hydride as our strong nucleophile. But before I do that, I want to make sure everybody is on the same page and really understand what oxidation and reduction is. You should have had this concept with Dr. Gurney in 114, in at least talking about oxidation reduction. But just in case it's been a while, I just want to spend 10 minutes going over and review oxidation reduction first before looking at specifically the reduction of aldehydes and ketones. All right. So in order to do this, we need to define oxidation level. Oxidation level is simply the number of bonds that carbon has to heteroatom. So oxidation level, you're going to ask yourself the number of bonds a carbon has to heteroatoms. And what are heteroatoms? I'm going to just define it as non-carbons and hydrogens. So, sorry, I need to look at the screen more so you can see everything that I'm writing. So number of bonds a carbon has to heteroatoms, which are non-carbons and hydrogens. So the probably most commonly found are the oxygen, nitrogen, halogens are the ones that are commonly found attached to carbon. All right. So here in the left, in this skinny box, I'm going to put the oxidation level, and I'm going to go from 0, 1, 2, 3 to 4. All right, as the categories. And we're going to look at the different types of compounds that will belong to, for example, oxidation level 1, 0, 2, 3, and 4. All right. So we're studying aldehydes and ketones, and that actually belongs to oxidation level 2, because this carbon has 2 bonds to a heteroatom, which in this case is an oxygen. All right. And by the way, you're looking at specific carbons at a time, and if you have more than one functional group, you're not adding oxidation level or anything first. So each carbon that has heteroatoms attached to it, you could define its oxidation level at that carbon. All right. So this is where we are at, aldehyde and ketone chapter. Now, one of the reasons why we study acid family in the next unit is because its oxidation level is higher, because it has not only the carbonyl but another oxygen attached, or another nitrogen, another heteroatom attached. So the acid family, including carboxylic acid and esters and amides and anhydrides, belong to oxidation level 3. All right. So this carbon with 3 bonds to heteroatom is oxidation level 3. The highest the carbon could be is oxidation level 4, because obviously carbon could only have 4 bonds. So for example, carbon dioxide is an example of oxidation level 4. And in terms of oxygen, we could have an oxidation level 1 in which you have an alcohol, for example, or ether. Those are carbons with oxidation level 1. And by that same token, we could also have 1 halogen attached to it, or you could have 2 halogens attached to it, or you could have 3 halogens attached to it in oxidation level 3, and then carbon tetrachloride is considered to be an oxidation level 4 because it's got 4 bonds to chlorine. All right. So that means that oxidation level 0 is going to have basically alkanes. So this carbon that we're looking at, if it has hydrogen or carbon, is going to belong to oxygen level 0. Those are alkanes. All right. So if we are just looking at compounds with just carbons and hydrogens, all right, it turns out when you have unsaturation, so alkenes belong to oxygen level 1 because of the unsaturation, and alkynes belong to oxygen level 2. All right. So what is determined as an oxidation change when you do a reaction in which you need an oxidation reagent? You're basically going from left to right, in which you are increasing in the oxidation level. All right. So if you go from alkene to alkyne, for example, that's an oxidation. If you're going from alcohol to aldehyde or ketone, that's also an oxidation. Whereas the reverse is called reduction, which is what we're going to be talking about. So when you're going from high oxidation level to a lower oxidation level, the way I remember is reduce. When you're reducing an oxidation level, that's called reduction. And obviously for reduction, you need to have a reducing agent. For oxidation, you need an oxidizing agent, right? In doing oxidation or reduction, so I'm going to call that redox, reduction or oxidation reactions. What happens in these oxidation reduction reactions is that the number of carbons do not change. All right, so that's how you know when there's a transformation if a reduction or oxidation is needed, rather than a carbon-carbon bond forming reaction or other things like that. So let's do a couple examples to make sure that you get this concept. Okay, so here are some questions. What is the oxidation level of the following compounds? So you're looking at this carbon, which has a heteroatom, so this is oxidation level 1. And what is the oxidation level of this? 1, 2, 3, 4. What is the oxidation level of this carbon? At this carbon is 1, 2, 3. But this carbon, and this carbon, this carbon, oxidation level is 0, right? Now, this is a very important question. Is the following transformation an oxidation, reduction, or neither? Right? So notice that same carbon framework is stays same, right? But here at this carbon, what is the oxidation level at this carbon? Is oxidation level 2, correct? And over here, what has happened is that that carbon has also oxidation level 2. So things are added, but at this carbon, the oxidation level is exactly the same. So this is telling you that this is neither an oxidation or a reduction. So you would need some different reagent, not an oxidizing agent or reducing agent, to do this transformation. Which of the following alcohols can be oxidized to acid, aldehyde to ketone? This should be a review for you from Chem 114. So that's an oxidation question. So let me just briefly go over that, and then we'll go right to the reduction. All right, so recall, so this should be a review of oxidation, because you already had alcohol chemistry. So remember, you had the primary, secondary, and tertiary alcohols. Primary had 2 hydrogens on this carbon. Secondary had just 1 hydrogen, so you had 2 R groups. And then tertiary had no hydrogens on that alpha carbon, right? So you learned some reagents, I believe PCC, which is considered to be the mild oxidizing agent, and that's the abbreviation for oxidation. Or you had a strong oxidizing agent. You might have chromic acid, or KMNO4, or some kind of strong oxidizing agent, right? So if you use PCC on these compounds, you're going to, this oxidation level is 1 for all these alcohols. And because you're oxidizing, you're going from oxidation level 1 to oxidation level 2 or higher, correct? So because PCC is a mild oxidizing agent, it transforms from 1 to 2, which means that in this case, you're going to have an aldehyde, right? Which is oxidation level 2. So if you do the same thing with this secondary alcohol, then notice you're getting, in order for you to form the double bond, you have to keep getting rid of the hydrogens. So remember, there's only 1 hydrogen in secondary alcohol. So after this oxidation, you're done. Whereas in tertiary, there's no hydrogen to remove in order to form the double bond. So there's no oxidation possible. All right. And regardless of whether in going from secondary alcohol to the ketone, whether or not you use the mild PCC or the strong chromic acid, it doesn't matter in this case because it could only go to ketone and then you're done. Whereas for the primary alcohol, there are 2 hydrogens to remove to form the double bond, right? So you remove the first one with the mild, but then let's say you want to go skip the aldehyde stage and go directly to the oxidation level 3 at this carbon, then notice that you would have to use a strong oxidizing agent, either the KMNO4 or chromic acid, in order to go from primary, which is oxidation level 1, all the way to oxidation level 3. If you want to stop at oxidation level 2 for primary alcohols, you would use the mild and it would stop there and not go any further. That's the difference between mild and strong. So if you use strong, it's going to take anything to the last final stage as possible. So for secondary, it will go all the way to ketone. For primary, it will go all the way to carboxylic acid. All right. So you should be able to, knowing this, answer the question about the oxidation, which one to acid, to aldehyde, to ketone. So you have to be able to draw these compounds first, and then figure out what reagent you would need in order to do the transformation. All right, that concludes this lecture, and I am going to use the next lecture to do the reduction.